Based on some of the homeworks that I've just been grading, I wanted to offer you guys a couple quick reminders so that you can do well on the test on Monday and or Tuesday. Just a quick review. Some of you guys need to review the sum of two cubes and the difference of two cubes, so you quickly identify those. And then, so let's get started on this first one. You know, doing problems that require grouping can be complicated, right? At first you might group them in pairs, and then for this one, you'll notice like that just doesn't work. Like that just doesn't help you. You're not noticing anything in common. So what that means is you can't give up. You just have to now try a different approach. So what I'm going to do here is the trickiest part is actually when I might give you a PST, and then it'll be minus a perfect square, so something squared. So as you can see, it's not quite going to work here, but if I rewrote this like this, now I have a PST minus a perfect square. So this approach is going to be sort of, you know, your last shot if you're like, I just can't figure out how to group this four-term polynomial. Often it'll be this tricky setup. And so what you want to do is then recognize that this is a mega dot, so you're not done. This is like something squared minus a y squared. So normally we would do like a something minus y, something plus y. And in this case, it's an x minus 3, which occurs in the front. So this is your factorization. Over here, this is a long, tricky one, and at first it doesn't seem like nothing's going to come to you immediately, right? So yes, sometimes I've set it up so that it should sort of jump out at you. You want to look for things that you notice are in common. So you're noticing an x squared, an a squared, and you notice that factors out really nicely. And I'm kind of noticing here, like really, I have to have this factor out, and I'm noticing there's actually hope that I will be able to see this part. So if I factor out a 3, yes, indeed, that works. So now my GCF is really this trinomial, and then I multiply that by a 3 and an a squared. But I'm not done. I have to ask myself, can I factor these? And I can factor this trinomial. And so this is my final factorization. Yes, indeed, it is frustrating and it is hard. This type of problem, you just have to tinker with it. Part of what I'm looking for is your perseverance. Will you ever necessarily see a 6-term polynomial like this in real life? No, not necessarily, because actually the problems you'll do in real life for your occupations will actually be more complicated than this. But what you will use in real life is your ability to be creative and try to figure something out and keep trying and not give up just because it's hard. So that's why I'm giving you some of these problems. So a reasonable approach might be seeing like, oh, we have these n's, r's, and x's with a minus, but I don't really see how I could put those together. So let me now try, like, what if I have the r's hang out together? So I have nr minus r plus this nx minus x plus, now I have to use these. Okay, so now I'll take an r out. Now I'll look at this, I'll take an x out. Oh, that's good. I like that. That's promising because I need these to be the same. So I take an a out of here. Okay, so guys, here's the thing. Like, all of these have to be the same because I'm factoring. And so I can't then group these together and get an n minus 1 times an r plus x, then plus an a times an x plus r. Or wait, hold on a second. Now, actually, I see that these are actually the same thing. So now I'm going to pull the x plus r out front, and what do I get? My n minus 1 plus my a. That is my factorization. You could have gone about that in a totally different way. You could have collected all your r's and all the x's, and it would have worked out differently. So then you would have an nr minus an r plus an ar, and then you'd have this negative x plus the nx plus the ax. Okay, so now I'm going to pull the r out, and so I'd get n minus 1 plus a. And now I'll pull an x out, and I'd get a negative 1 plus n plus a. Now, I know these have to be the same. They're not looking the same. Oh, but actually, I could rearrange it and use the commutative property and just say n and then minus 1 plus a. So these are the same, actually. And then I'd have an r and an x. Oh, and that is exactly the same answer. Cool. So that does work out. Nice. So yes, these are some more challenging problems, but again, it's your ability to sort of tinker with them, to persevere, to keep trying, and to not give up. I have to say, it's really disappointing when you guys are like, prime, yeah, it's prime, without just writing anything. That really, to me, it is hard, because I really want to see you guys like really try to fiddle around and explore this. And I'm happy to answer questions. If you're having trouble grouping them and you want to show me that you've tried to group it this way and you've tried to group it this way and it just didn't work out, awesome. Once I see that you've put in some work, I would love to help you. So make sure you ask some questions on the test.